Hey y'all, welcome back to ASP NET from scratch. In the previous episode, we looked at the label, text box, and button controls, as well as the mail message and SMTP client classes to build a web forms application called Email Form. It's a contact form where the user can fill out the form and send us an email. Now, it works okay, but it's lacking some usability features. For example, when the user clicks the submit button, they don't have any idea whether or not their email was sent successfully. So we're going to spend some time in this episode finishing that application. When we're done with that, we're going to spend some time with the C# programming language. In the previous episode, you were kind of thrown in there without any idea of what was being typed on the screen. So we're going to spend some time with the fundamentals so that you can get a better grasp of the language. So let's get started. The first thing we'll do is we'll tell the user when the email was sent successfully. To do that, we'll go back to our user interface file, and at the top of our form we're going to add another control called a panel control. A panel control acts as a container for other controls. It can also contain HTML markup or just some plain text. I'm going to set its ID to PNL success, and I'm going to set the runAt attribute. ASP.NET renders the panel control as a div element, and naturally anything inside the control is also inside of the div element. I'm going to add a P element, and I'm going to add the text, your email was sent successfully. As it stands now, when the user first views our form, they're going to see this message, and we want this message only visible when the user submits the email and the email is sent successfully. So we're going to add a property called visible, and we're going to set it to false. This property is different than the CSS visibility or display properties. When visible is set to false, ASP.NET does not render this control at all. It is completely absent from the HTML markup. So if we want to completely hide some message or a group of controls, we can set the visible property to false and it will not show up in the HTML. Since we want the contents of the panel control displayed whenever the user's email is sent successfully, we need to set this visible property to true within our code behind file. So we'll just add a line after the SMTP client class sends our email message, and we'll just set PNL success visible is true. We can also add some visual cues to let the user know that everything is okay. For example, we're going to clear the text from the text box controls. This, along with the message at the top of the form, will instantly tell the user that everything is working okay. To clear the form, we'll write a method called clearForm. I know that we will spend some time with C# a little later, but I'll go over the different parts that make up a method definition since we need to add this clearForm method now. The first part of a method is its accessibility level. There are several levels of accessibility, but you'll use public, protected, and private more than any other levels. Any class members set as a public level have no accessibility restrictions. You can access public properties or methods from within or from outside of that class. The protected level limits access to the containing class or to subclasses of the containing class. And the private level limits access to only the containing class. You determine what protection level to apply to a property or method according to how you want to use that member. I'm going to set the clearForm's method access to private. We don't really need to access this method from outside of this class, so private makes the most sense. Next is the method's return type. If this method were to return, like for example, an integer, we would specify that here by using the int keyword. But since we are not going to return any type, we're going to use the void keyword. Next comes the method name, followed by the parameter list. And the parameter list is inside of the parentheses. This particular method isn't going to accept any parameters, but if we wanted it to, we would simply add a parameter by first declaring the type of parameter. I'll use a string for example, and then we'll give the parameter a name. Something like that. And if we wanted to add another parameter, we would just hit the comma and then we would add another parameter. but we don't really need that, so we'll clear that out. And then we just need to add the curly braces, and now we have defined a method. We can go about clearing the text from the text box controls in a number of ways. First, we could list each text box and change their text properties to an empty string. However, that approach can get rather tedious, and we'd have to modify this method every time we added a new text box to the form. Instead, we'll loop through the controls within the form. We'll identify the text boxes, and we'll set their text properties to an empty string. Since we're going to use a loop, we need to determine what kind of loop we want to use. We could use a for loop, and if you're familiar with other C-based languages, the for loop will look very familiar to you. You first use the for keyword, and then you initialize the index variable. I will create an integer called ii, and I'll set it to 0. Then is the condition statement. ii is less than form1, controls count, and then we increment the index variable ii++. Now, to access each element within the controls collection, we could do something like this. Control equals form1 controls. We would use the open square brackets. We would type in the index variable and then the closing square brackets. We can do this much easier with a different loop called the for each loop. For each loops are designed specifically to loop through each element in an array or a collection. Many ASP.NET controls have a controls property. The IntelliSense tells us the controls property is of type control collection. The collections in the framework class library are pretty descriptive as to what type of objects the collection holds. Since the word collection is prepended by the word control, we can determine that the control collection class is a collection of control objects. Now, remember in part 1 when I said that controls are classes? Well, all controls are subclasses of the control class. Therefore, all controls are instances of the control class. So the controls property contains all the control objects that are contained within this form1 object. So to write the for each loop, we'll type the for each keyword, then the variable that matches the type contained within the collection. In this case, control, and we'll call the variable control. Then we use the in keyword, and finally the collection to iterate through, form1.controls. The scope of this control object is limited to only this loop. So I can go outside of the loop and I can type control, and you can see that it's prompting me for the control class, but there is no variable with the name control here. Now that we have a loop to iterate over the controls within the form, we need to determine which controls are text boxes. So inside the for each loop, we'll use an if statement, and we'll test if the control is a text box. Now remember that the control collection class contains a collection of control objects. The control class is very generic, and we can tell that by looking at the IntelliSense. As you can see, there's no text property here. So in order to gain that functionality, we have to cast or convert this control object to a text box. To do that, I'm going to create a variable of type text box, and I'm going to call it text box. And then I am going to use the as keyword to cast it as a text box. And now I can access the text property, and I can set it to an empty string. Now here I've used the static property of the string class called empty. This is equivalent to using double quotes, so I could do this instead if I wanted to. I use string empty because for me it's a bit easier to read and comprehend when I'm scanning through code. Feel free to denote empty strings however you want. Just be consistent in doing so. So I'm going to clear this line with the double quotes, and I'm also going to call the clearForm method after the success message is shown to the user. And since we've made quite a few changes here, I'm going to press F5 to run this, and we're going to test it out. For the name, ASP.NET from scratch. Email, ASP.NET from.scratch@gmail.com. For the message, I'm just going to put testing new changes. Now whenever I click the submit button, we should see a message appear at the top stating that the email was sent, and the text in the text boxes should be cleared. And there we have it. Everything's working okay. So now we need to tell the user when our app fails to send the email, and we can do that by identifying the pieces of code that generate an error and to handle those errors. Now in the .NET framework, you will rarely see the word error. Instead, you're going to see the word exception. So when you see exception, you can think of errors. To identify these pieces of code, we can use IntelliSense. I'm going to move my mouse over the mail address constructor, and IntelliSense is telling us that this constructor can throw 3 different types of exceptions. I'm going to move over to the send method of the SMTP client class, and you can see that this method can throw 6 different types of exceptions. Now, in order to handle these exceptions, we need to use a try-catch block. And so at the top of our code, I'm going to add a try and then open curly brace. And then after the clear form call, I'm going to add a closing curly brace. So what we're doing is we're essentially trying to run this code. And if an error occurs, then we need to catch that exception. So we're going to use the catch keyword. And then we need to determine what type of exception that we want to catch. One particular exception, I'm going to go back to the send method, is the SMTP exception of system.net.mail. So if we wanted to catch only that type of exception, we could catch only an SMTP exception. And so we could add another catch line for a different type of exception so that we can catch every exception that's listed, and we can provide a different error message if we wanted to. That can take quite a bit of time, and we want to save time and save code as well. So I'm just going to catch an exception because all exceptions are actually subclasses of the exception class. So since I'm catching an exception object, every exception that is thrown will be caught, and I can handle that code here. So now that we're catching every type of error here, we need to go back to our user interface file, and we need to tell the user that an error occurred. So to do that, I'm going to add another panel control. I'm going to give it an ID of PNL error. I'm going to set the run at attribute. I'm also going to set its visible property to false. Inside, I'm going to add a paragraph that says your email was not sent due to an error. Then I'm also going to add another line to display the error message. It may not be very helpful to the user, but if I need to debug this application, then I at least know where to start. So I'm going to put error message, and then I'm going to add another type of control called a literal control. I'm going to give it an ID of LT error message. I'm going to set the run at attribute. Now the literal control is just what its name is. It is a literal. There is no markup that is generated for this control. Instead, whatever you pass to its text property is what is displayed on the page. So that could be HTML, that could be some type of entities, it could be just plain text. So ASP.NET does not generate any type of markup for this control. So now we have everything in place in our UI file. So let's go back to our code behind, and we need to set that panel's visible property to true when an error occurs. So we're going to type PNL error, visible is set to true. We also need to access that literal control, LT error message. We are going to set its text property, and we are going to use the exception object that was created here. We didn't have to create this, it's done automatically for us. So we're going to type EX, and then we're going to use the message property. Now off screen, I went back into my web.config file and I changed it so that it will try to connect to a non-existent SMTP server. So I'm going to run this, and I'm not really going to worry about anything that I'm going to enter here. I'm going to click submit message. And we can see that we've already got a message here. And the error message is stating that the specified string is not in the form required for an email address. So the only email address is this email field here. So I'm going to set this in the form of a true email, and we're going to click again. And we can see that our email was not sent because there was a failure sending mail. Well, that's not very helpful. But at least if we're trying to debug this, we know that it is something network related because it tried to send the email, but it couldn't. Whereas that first error that we generated was due to a user error here. So it doesn't matter what type of error occurs, the user is going to see the error message. And if we need to debug it, then we can at least have a starting point. And that's going to wrap up the email form for now. As with any application, we could spend more time making this better, and perhaps we'll revisit it in a later episode. But for now, we're going to switch gears and look at the C# programming language. This has actually been running in a virtual machine, so I'm going to close that down, and I'm going to start up Visual Studio 2010. This is Beta 2. It is freely available to download. In fact, if you want to look at any edition of 2010, you can find a beta download for it. And since we're on the topic of free software, if you're a student, you can go to www.dreamspark.com. And if you can verify that you are a student, you can have access to any of these software solutions that you see here. Verification can be as simple as using your email if you have a .edu email. If you don't have a .edu email, then you're going to have to jump through a little bit more hoops to verify that you are a student. But it's well worth it if you want to get into Microsoft development as far as ASP.NET or Windows development, because you can get access to Visual Studio Professional Edition. You can also get access to Windows Server 2008 and 2003. They also have the Expression Studio and Microsoft SQL Server. So if you are a student and want to get into Windows development, this is a great program that you can take advantage of. The name of C# comes from music theory. Here is a partial keyboard layout. This has 3 octaves. This key here is one of the C keys, and C# is a half step up in pitch, which is this key here. So the idea behind the C# name is similar to the name of C++, that C# is a step above C and C++. Now the background information behind .NET and the C# language varies depending upon who you talk to. The common unconfirmed rumor is that C# and .NET are a result of the legal battle between Microsoft and Sun Microsystems over Microsoft's Java VM implementation. As a result of that legal battle, Microsoft had to keep its hands off the Java language as well as its Java VM implementation, which Microsoft had been adapting to the Windows platform. So Microsoft decided it'd bring its own solution to the table with the .NET framework and the C# language. Many Microsoft detractors automatically dismiss C# as a Java clone. Well, that's not really fair to the language or the people who worked on it. C# is a great language, and it provides many improvements over its C-based ancestors. What you see here is the new start page that comes with Visual Studio 2010. As you can see, it's quite different from that of 2008. It has a lot of the same concepts, but it's just organized a little bit differently. Since this is the professional edition, we have quite a few choices to choose from as far as getting resources. We can also download RSS feeds from MSDN if we wanted to. Now earlier I created a console application project so that we can go over some of the fundamentals of C#, which we're going to start with variables. You can think of variables as boxes in your computer's memory, and these boxes can hold any value so that your program can process it. There are many different types of values that can be stored in variables, and you must specify what type of data that variable will hold when you declare it. To declare a variable, you declare the type and the name of the variable in a declaration statement. Here I'm declaring a variable called age. It is an integer type, which is a whole number. Int is short for integer, and it's a keyword that is an alias for the system.int32. So if you wanted to write this declaration statement like this, you could. However, I don't know anybody that doesn't use these shorter keywords. Now, even though I have declared this variable, I can't use it yet because it hasn't been initialized. You initialize a variable by assigning it a value. I'm going to assign this a value of 30. So now, since int has been declared and been initialized, I can use this in my code if I wanted to. Now I don't have to declare an initialize on two different lines. If I wanted to, I could do it all on one line, so I declare and initialize the age variable on the same line. The integer data type is what's called a primitive data type, and C# has several built-in primitive data types. So if you want a whole number, the int data type is a primitive data type that you can use. If you need a whole number that is larger than what can be stored in an integer, you can use the long data type. There are also floating point numbers and double floating point numbers. There is a problem though with floating point numbers in math, and it's not really a problem with C#. Pretty much every language that uses floating point numbers does math incorrectly with them, and it's not really a problem with the language, it's just how it's done. So if you need something that's accurate that uses decimal places, there is the decimal data type. And there's also a string primitive data type. But it's a little bit different, and we'll go over that here in a few minutes. Now, with the exception of the string type, these primitive data types are called value types. They're called value types because they directly hold the value that they are assigned. So this age variable actually holds the value of 30. I'm going to declare another variable called age2. I'm going to initialize it with the value contained in age. This new statement copies the value contained within the age variable, and it assigns that copy to the age2 variable. So both of these variables contain the value of 30, but they are two different copies of that value. So I could modify the value contained in age, and here I'm going to double it. And it doesn't affect age2 at all. So age2 is still 30, whereas age here is now 60. If a data type isn't a value type, then it's a reference type. Variables of reference types, which are called objects, store the references to their value, not the value itself. So I'm going to add system.xml to the using statements. Then I'm going to create an XML document object called XML_doc. I'm going to call its constructor. Then I'm going to create another XML document object called XML_doc2, and I'm going to assign it XML_doc. Now what happens in these two lines of code is a little bit different than what happens here. With the integers, we have a value of 30. That value is copied, and that value, or that copied value, is stored within age2. What happens here is a copy is made of the reference to XML_doc, so that's actually a space in memory that references that object. That memory address is copied and stored within XML_doc2. So we actually have two variables referencing the same object. So if we wanted to, we could go and do XML_doc2. We could call the load_xml method. And the load_xml method just loads the string that you pass to it into the document. So we have added a root element called document root to XML_doc2. If we were to print out the XML of XML_doc2, we would just see this root element here. If we were to print out the XML within XML_doc, we would see the same thing. So these two are linked, and they are related to each other until we break that relationship. To break that relationship, we just simply assign a new value to XML_doc or XML_doc2. So we could call the constructor again to create a new object that would break that relationship, or we could just assign null, so that this object is now null until we assign it a new value, and that also breaks the relationship as well. One exception to this discussion of value types and reference types is the string class. The string class is technically a reference type, but it behaves like a value type. So I am going to create a variable, a string variable called hello, and it will contain the string hello. I'll create another variable called hello world, and I'll assign it hello. Now this is an object, this is a reference type, but what happens here is we copy the value hello and assign it to hello world. So these two variables are independent of each other. So I could modify hello world, and if we were to print out these two strings, hello would still be hello, and hello world would be hello, comma, world. The difference between value and reference types is an important concept to understand because it can save you from making errors when formulating a solution to a problem. Now, a variable's scope is determined by what block of code you declare it in. For example, these variables are all declared within the main method, and right now there's only one block of code within that main method. If I tried to use these variables outside of this method, I would get an error because these variables would be out of scope. So these are local variables for the main method. Now, I'm going to add another block of code here. It's just going to be an if statement. And I'm going to put the string variables inside of this if block here. Now, scope flows from top down. So these variables here are local to the main method, and since they are at the top of the scope, they can be accessed within any other nested scope. However, the string variables are only in scope inside of this if statement. So I can even add an else. And you can see from the IntelliSense that it's not pulling up the hello variable here. So all of these variables are only in scope inside of the block that they are declared in. And something else I haven't mentioned, conditional statements have to evaluate to either true or false. There are no truthy or falsy values. So if you want to see if a particular object is null, you have to actually use the equality operator or the inequality operator to see if a particular object is null. And also something else, null is only valid for objects. You cannot use null for value types here. In fact, if I tried to do this, I'm assigning a value type, an integer, a value of null, and you can tell that Visual Studio doesn't like that at all. There are some ways to get around that. We'll talk about that more in the next episode whenever we start dealing with databases and interfacing with databases. If you wanted to have a variable that was in scope throughout the entire class, you would add what's called a field. A field is a variable that is declared directly in a class. There are two types of fields. There are instance fields and there are static fields. Instance fields are specific to a particular instance of a class. They belong to the instance, but they are members of the class. For example, we have class program here. I'm going to add an instance field. It's going to be a string. I'm going to call it name, and I gave it a value of ASDF. If I were to create two objects of this program class, then I would have two objects with a name of ASDF. But if I took one of those objects and changed the value of name to FDSA, then I would have one object with a name of ASDF, then I would have another object with the name of FDSA. So instance fields belong to the instance, they don't belong to the class. Static fields, on the other hand, belong to the class, and they are shared among all instances of that class. So if you make a change to a static field, then it's going to be seen by every instance of that particular class. To create a static field, you simply use the static keyword. Like here, I'm creating a static field called static name, and I'm going to give it a value of ASDF. Now, this field belongs to the class. So if I have those same two objects from earlier, if I change the static name field to FDSA, then those two classes are going to see that change. And whenever I use the static name field, it's going to give me the value of FDSA until I change it again. Static members cannot access instance members. Remember that static members belong to the class, and they're shared between all instances of a class. So a static member would have a hard time identifying what instance to pull data from if you wanted to pull data from a particular instance. On the other hand, instance members can access static members. So there's a one-way relationship between instance and static members. As a general rule of thumb, you want your fields to be either private or protected. You don't want them public. If you want to expose data from your class, then you want to do that with methods or properties. By default, if you do not specify a protection level, then it is implicitly private. But you can explicitly say private, or you can say protected as well. If you wanted to expose this name field, which is an instance field, outside of the object, you can create a property. Defining a property is somewhat similar to declaring a field. You first specify its protection level, then its data type, and since we are creating a property to access the name field, our property needs to be string, and then there's the property name. If you wanted to create a static property, you simply put the static keyword between the protection level and the data type. Now I've used an uppercase N here. This is a convention of the .NET framework. All namespaces, all classes, and public properties and methods start with an uppercase letter. All local variables start with a lowercase letter, but instance variables and even static variables are kind of up in the air, and it really depends upon the developer. Some developers simply use the same type of naming scheme as public properties. Some will prepend it with an underscore, and even some will prepend the underscore with an M. So it really doesn't matter, just as long as you're consistent and as long as you, or more importantly somebody else, can read your code and know what you're doing. This is where the similarities end between defining a property and declaring a field. Instead of using the assignment operator, we're going to open with a curly brace. Now, properties are actually special methods called accessors. This enables you to expose the data that you want to expose while still providing the flexibility of methods. There are two accessors you can use when creating a property. One is get and one is set. The get accessor returns a value. So in this property, I'm going to return the value of the name field, like this. I simply use the return keyword, and I'm returning the name field, and then a semicolon ends the statement. If I wanted to, I could modify what the name property returns by simply adding more here to the return statement. So now as somebody used this name property to get a value, they would get the string hello, comma, then followed by whatever is assigned to the name field. Since this property currently doesn't have a set accessor, this property is considered read-only. So someone using this class could retrieve information from the property, but they wouldn't be able to set a new value. To enable that functionality, you use the set keyword. The value passed to the set accessor can be referenced with the value keyword like this. So you can think of the value keyword as a parameter passed to the accessor. Since accessors are specialized methods, you can add code to validate the value being assigned. So if you wanted to, you could use an if statement to see if the string that's passed to this property is null or empty. And if it is, then you can throw a new exception. The value passed to name is invalid. So if anybody was using this class and they didn't assign this name property a valid value, whenever they ran their code, they would see an exception, which they would then have to handle. It's also possible to set protection levels for accessors. You can make it so that the set accessor is private, and only code from within the class can then set a value for this property. We'll close this episode by writing a simple class that represents a circle. We'll apply some of the concepts that we covered in this episode, as well as a few other concepts such as constructors and overloads. I'm going to go to the Solution Explorer. I'm going to right-click on the project and go to Add, and then I'm going to choose Class. It'll pull up the Add New Item dialog box with class automatically selected, but it'll give me other options just in case if I misclicked something. I'm going to change the file name here to circle, and press enter, and it automatically generates a class for me, and it is called circle because that is what the file is called. It places this class within the namespace that is the default namespace for this application, which is console application 1. Now the first thing I'm going to do is I'm going to add public in front of class. I like to be explicit when it comes to defining what is private, protected, or public. Next, I'm going to create a default constructor. Now a constructor is public, private, or protected, and it has no return type, but its name has to be the same name of the class. A default constructor does not accept any parameters, so we're not going to put any parameters into the parentheses and then the curly braces. So a constructor is a lot like a method. It doesn't have a return type, but it does have a name, and that name has to match the name of the class. Now default constructors are handy whenever you want to initialize private fields without needing input from the user. We don't have any private fields right now, so we're going to add one. It's going to be private. It's going to be a double floating point number, and I'm going to call it underscore radius. This is how I like to define or declare private fields. I like to prepend it with an underscore, and then the first letter of the word is capitalized. So now we have a field that we can initialize in our default constructor, so I'm going to give it a value of 0. So if we were to create an object of this class, and we called this default constructor, we would have a circle object with a radius of 0. So we could run some computations if we wanted to. Now we also want to allow anybody using this class to create an object and initialize the radius at the same time. To do that, we do what's called overloading, and we are going to overload the constructor. So we are going to write another constructor, except this constructor is going to accept a double floating point number called radius. And then inside we will initialize our radius field with the data that is passed to this constructor. Overloading is a feature that allows us to write flexible code for other programmers. It's not a feature specific to C#. It's a feature of object-oriented languages. To overload a constructor or a method, you have a constructor or a method with the same name, and then the parameter list is different. This is called the signature of the constructor or the method. This constructor's signature is a double floating point parameter, whereas the signature for our default constructor is no parameter. So we could add another circle constructor. We could tack on a string value, and this would be a different overload for our circle class. So we could call this constructor, or we can call this constructor, or we can call this constructor, because they all have a different signature. Now if we took off this string and we left this double floating point, we would have a problem here because we would have two constructors with the same signature. Next we'll add a property to provide some access to our radius field. So we'll do public double radius. Our get accessor is going to return the radius field, but our set accessor needs to provide some validation. Whoever is using our class could pass a negative number to our radius property, and we can't have a radius that's negative. So we need to make sure that any data that is passed to radius is valid. So first we need to see if the value is less than 0, and if it is, then we'll throw a new exception. Radius cannot be less than 0. And then we'll simply assign our radius field a new value, and we'll close out with the curly brackets. The last thing we're going to add is a method to compute the area of our circle. So we're going to use the public keyword. It's going to return a double floating point number, and the method is going to be called area. It's not accepting any parameters because we have most of the information we already need. We have the radius, so the only other piece of information we need is pi, and pi is easy to get to. But first we need to put in the return keyword because we are returning a value. Then we're going to use the math class, and it has a static property called pi. Then we simply multiply radius 2 times, and now we have an area method. So let's see this in action. Let's go back to program.cs and let's clear out all the code that I added earlier. I'm going to create a circle object. I'm going to call it circle. And for the constructor, I can either call the default constructor and set the radius later, or I can just pass it a value, and I'm going to pass it a value of 2. Now this is a console application. It is going to run it in a console window. And so I am going to use the console class, and it has a static method called write. And I am going to write to the console the results of the area method. Now, if I ran this right now, it would run the application and then close it immediately because it is a console application. So I am going to add a variable called II and just initialize it as 0. And I'm going to set a breakpoint here. Now breakpoints are used primarily when you are debugging an application. We're going to get into debugging in many episodes later. But basically what this does is this halts code execution on this line. So it's going to create the circle object, it's going to write the area to the console, but then it's going to halt on the line where we created this II variable. So I'm going to run this, and it appeared on my other monitor, so I'll drag it over, and we can see the results of the area method for a circle with a radius of 2. The area is 12.566, and then a whole bunch of other numbers. And so that we're going to end this lesson. I know we didn't go deep into the C# language, but we learned quite a few fundamentals. We learned about for and for each loops and how to loop through collections. We also learned how to handle exceptions to make our apps more user-friendly. We learned many of the basics of the C# language, primarily about variables, fields, properties, methods, classes, and constructors. I hope this gave you a starting point to get better acquainted with the language if you weren't already. In the next episode, we're going to talk about databases and how to interface with them using ADO.NET and link to SQL. So until then, I hope you have a good couple of weeks, and I'll see you next time.